Very good morning to everybody. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? Yeah, I think we are live. Yeah, first of all, do comment करके बोलिए ना. Is the audio videos clear to everybody? चलिए चलिए आज का सेशन हम शुरू करेगा. 1 million plus grade aspirant has joined with us. 1 million plus gate aspirants have joined with us. So if you also want to be part of Unacademy, so do join immediately. One subscriptions. With this, you'll get the rank, top educators and better ranks. You can start your serious preparation for GATE 2027 just 8,499 rupees only. With this, आपको क्या मिलेगा? Live classes by top educators, PYQs and test series भी आपको मिलेगा. And syllabus complete by October. We'll finish the complete syllabus and 3 months पर revision and practice के लिए 3 months आपको मिलेगा. So do immediately subscribe and use the code of BV Reddy. Use the code of my personalized invite code of BV Reddy and to have the great learning from the top educators. It is a limited period offer. Last live batch we started. You can have a look at now from the gate toppers, the top educators of India. We started. So we started on the 24th July. हमने नया batch शुरू किया. Control systems and the network C starting. And this batch is for 2028 के लिए control systems and networks. And we are providing the test series also. You can see now MahaSangram test series for GATE 2027 के लिए. So totally how many tests you can see now? 73 tests, and that is just 14,999. 1,499 rupees only, not 14,000, 1,400 only. So use the code. इतना कम प्राइस में नहीं मिलेगा ना, so मैंने सोचा कि 14,000 नहीं 1,400 में मिलेगा. ठीक है. So you can use a code of BV Reddy. And so to know where you stand in the all the gate aspirants, and the exam is completely exactly like a final gate exam only. That is computer based test, and after completion of the test you will get complete analysis आपको मिलेगा. So where you did the mistakes, आपने क्या किधर किधर गलत किया, so what are the mistakes, you can able to rectify your mistakes, and then उसका solutions भी आपको मिलेगा. And the solutions, with that you can able to clear your doubts and you can able to interact with the educators where what happens. And then these are created by the top educators. And these are the GATE 2026 rankers from Unacademy team का EC and electrical का केवल. And ESC 2025 का rankers you can see now for all the branches. So you look at now how many rankers are there. You can have a look at now. Now we do offer the 2 subscription plus wala as well as the iconic. एंड प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स होगा, एवेल्युएटेड टेस्ट सीरीज भी होगा, स्ट्रक्चर्ड कोर्सेस एंड पीडीएफ लाइव टेस्ट, अनलिमिटेड एक्सेस. once you join you can able to watch the any number of times any educator classes. There is no restriction for it. राइट। सो आइकॉनिक में एडिशनली आपको क्या मिलेगा, पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स आल्सो आपको मिलेगा एडिशनली, जो इधर प्लस में मिलेगा इसके साथ एडिशनल बेनिफिट। राइट। एंड mentorship program, you can interact with the educators according to your time convenience, book a time slot and connect with the educators. So let's start your serious preparation to achieve your dream goals. And let's coming to the course what we have planned. So here this course have planned for the गेट 2027 एस्पिरेंट्स के लिए हमने प्लान किया इस कोर्स। यू कैन हैव अ लुक एट दिस इज द नेटवर्क कोर्स फॉर गेट 2027 who are seriously preparing for 2027 के लिए this course is almost daily 1 to 1.5 hours we are planning the classes. Okay, if there is any emergency urgent meetings are there, so then those days we don't have any class. Right. Remaining days maximum I'll plan the classes for 2027 के लिए. So this course which will be helpful who are seriously preparing for the GATE 2027 के लिए preparation students होगा ना, इसका बहुत काम आएगा. Now, so in this course, we are going to discuss each and every topics in detailed manner. Yeah, this course, of course, this course will be for the branches of EC के लिए, and this course is for the electrical, and this course is for the instrumentation students also, IN also. For the, all these three branch students can able to avail this opportunity. Okay, so I'm planning this course in detailed manner. So then according to your requirement, do comment in the comment section what we need to plan it. So then based upon that, I will provide you the requirement I will provide you. As I planned this thing, this course for GATE 2027 के लिए मैंने प्लान किया to discuss the each and every concept in detailed manner. इसके साथ प्रॉब्लम्स पर फोकस भी करेगा. इधर इस कोर्स में हमने ज्यादा से ज्यादा प्रॉब्लम्स करेगा. व्हाट वी कैन डू हियर, complete syllabus will be covered, variety of problems are discussed, all the topic problems are discussed, each and every topic problems also discussed, right? So you can avail these opportunities. You can use this opportunity to make your concept is very strong. So आपने so here कई इंस्टीट्यूट में आपने so ये networks so prepare किया होगा. You might just learn this network from so many other institutes and academy, कुछ our institute से भी आपको follow किया होगा. बट लेकिन इधर हमने प्रॉब्लम्स पर फोकस करेगा. ये इतना प्रॉब्लम सॉल्व करने के बाद आपको बहुत बहुत कॉन्फिडेंस मिलेगा. Variety of problems will be discussed from basic level to GATE ESC. All the PYQs भी हमने डिस्कस करेगा. So daily, so I'm requesting you all of you fellows daily 1 घंटा हमारे साथ स्पेंड करो, देन ताकि आपको बढ़िया से बढ़िया नॉलेज मिलेगा. ठीक है, इस कॉन्सेप्ट में. सो नेटवर्क्स के लिए, इसके नेटवर्क्स होने के बाद अब दूसरा सब्जेक्ट भी हमने प्लान करेगा. अभी तो हमने केवल नेटवर्क्स प्लान किया, इसके बाद विल सी दिस थिंग. राइट, चलिए लेट्स स्टार्ट आवर डिस्कशंस. And control system when start in YouTube. Control systems. Okay, so then as of now I have planned this as a networks I have planned here. So then if your demand is for this as a other subject, we can do. No, so this is, you can ask me the subjects of the this is networks, digital signals, controls, EMFT subjects. Okay. So this is a core electrical subject. I don't handle the core electrical subjects. I won't handle the core electrical subjects. Okay. So now, as of now, I plan this as a networks. Thereafter, we'll do for the control signals. Yes, like that we do one by one. ठीक है? चलो. So let's start now here. First one. So networks assignment one. We are starting now here. We'll try to cover the each and every problems. We'll try to discuss now one by one. ठीक है? चलिए. Now, yeah, take this problem. Calculate the equivalent resistance. Find the equivalent resistance. Do that one. Now you can tell me now here. Very good morning. So here, first of all, you tell me now how these two resistors you tell me now here parallel. So how much this value tell me now? We can say this is 10 into 40 by 10 plus 40, which will be a 50. So 0, 0 will get cancelled and this is 5 twos. This will come to be how much now? 8 ohms now. So this value 8. And yeah, you can tell me now here how these two resistors now. This also parallel. So how much we can say now here? 5 into 20 by 5 plus 20. So that is 25. 5 fives. This is 5 fours, which will be equal to 4. Now, how about this 8 and this 8 and 4? These two are series now. So what we can say now, RAB, which will be equal to 12 ohms. Okay. Calculate the equivalent resistance RAB at terminals AB. Now you can see now here, right? So these resistors, we have three resistors are there. Three resistors. How these three are in parallel. So we'll find the equivalent of this. For this, I'll give one trick I will give to find the equivalent resistance. Look at now here, trick to find the equivalent resistance. You see this thing here. If we have a 2 ohm resistor, if it is parallel to 4, what we need to do here, 2 into 4 by 2 plus 4 will do. Instead of that, we use one simple trick we use now here. 2, this is parallel to 4 now. I'm using this symbol for indicate the parallel. So here the 4 means 4 by 1, 2 means 2 by 1. Now, so we are equating the numerators, we are equating for both the terms. So here the numerator is 4 now. So that's why we are making this also 4. To make this is 4, we need to divide with 2 now. Now the numerators are equal. The numerators are equal, right? So that means which is equal to 4 by. Now denominators are simply add karo. That's it. That is what tell me now 4 by 3. Understood this step? Tell me. Numerators are equal. So denominators को add करो simply. Okay. Next, so for example, if we have a 2 parallel to 4 parallel to, we have 8 is there like this. Let us consider. Now you tell me now what we can do here. 2 parallel to 4 parallel to 8. Now what I'm doing is, now we make the numerators are equal. So here this is 8 by 1. So I am multiplying with the 2, divide with the 2 here. Here multiply with the 4 and divide with the 4. Now the numerators are equal. Numerators are equal. So that's why we'll have what, tell me now, this is 8 by 4 plus 2 plus 1. That is what we can say now, 8 by 3. Understood this step? Tell me now to solve it. Right. Now here coming to, in this case, look at this problem now here. Here 60 parallel with what, tell me now, 20 parallel with what, tell me now, 30. So what I need to do here? So multiply with 2, divide with 2. Okay. Now this is multiply with 3, divide with 3 now here. Multiply with 3 and divide with 3. Now this is 1. So what I can say now, this is 60 by 1 plus 3 plus 2, which will come to be a, oh, this is not visible now, sorry. So this thing, what we can write now here, this is 60 parallel to what, tell me now here, 20 parallel to 30. Yeah, tell me now what we are doing now here. This multiply with 2, divide with 2. Now this is 60. This is multiply with 3, divide with 3. Now, so this is denominator is 1. Now you tell me now this equivalent, what I can say is 60 is there, 60 by 1 plus 3 plus 2. So which will be come to be a, what tell me now, 60 by 6 now, and which will be equal to 10. So how much is value, tell me now? 10. Now this 10 and this whole value which is a 10. 10, 10 are in series will becomes as 20. So finally what we have, tell me now, this RAB, tell me now. So this is 80 parallel to 80 parallel to 20 now. So here also we do the same technique we can apply. Tell me now here, 80 parallel to 20. So what I'll do here, multiply with 4, divide with 4, and this is 1. So what I can say now, this is 80 by 5, which will be equal to what, tell me now, 16. Isn't it? Next one. Calculate the equivalent resistance RAB. Equivalent resistance RAB at the terminals A and B. Now tell me now what we can do here. Equivalent resistance के लिए what we can do now here. So first of all, you can see now here this is A, and here, yeah, this is A. Now here this point which is also A only, up to here there is no element here. So I can say this point is also A only. Let us say this point is C, this point is B, this point is also B. Now let's redraw the circuit now. We'll redraw the circuit. So you can tell me now here. So this point A we have, let us say this point is C, and this point we have it as a B. Now you tell me now, A to C we have a 5 ohm resistance is there. So this is a 5 ohms. Next C2B, we have a 2. C2B, we have this is 2 ohms. And C2A, C2A and A2C both are same only, na? So this is the resistance. How much is value? 20. Next, A2B. This is from A to B now here. So how much we have? 3. Now simplify now here. Do simplify this thing here. How these two you tell me now? These two parallel. So how much is value now here? 5 into 20 by 25. So this is 5 fives and this is 5 fours. So this value is a 4. 4 and 2. So this value is 6. 6 and 3 parallel. So this will come to be a what element now? RAB. So that is 6 parallel to 3. That is nothing but 6 by 3 na, which will come to be a 2 ohms. Okay. Next one. Now here we have the 4 resistors now here. How these 4 resistors are now parallel and these two are in series. How much we can say now? 55 I can write. And these 4 are parallel. So you can tell me now here 10. So parallel to what you tell me now? And this is 40. 40 parallel to 20. 20 parallel to what you tell me now? 30. Okay. Yeah, you can see now here. So we need to make the numerators are equal. So इसलिए what I am doing now here, multiply with 4, divide with 4. Now this is numerator is 120. So that means this is multiply with 6, divide with 6. This also 120 and this is multiply with 3, divide with 3. Now this is multiply with 12, divide with 12. Check it all of you. Now, so this value, how much is equivalent? You can tell me now. This is 120 by, so tell me now, 12 plus 3 plus 6 plus 4. So how much is value? 120 by, this is 25 now, isn't it? 25. 120 by 25. So this means how much this value will come? You see this thing. So this is 5 fives and 5 twos for 24 by 5. That means what will be the 4.8. And this 4.8 and this 55. This is a series only. So that's why RAB, which will be equal to 55 plus 4.8. That is nothing but 59.8 ohms. Right. And take this problem. This is another badhiya problem. Let's see how we'll solve it. Now this is 10 ohm. Here we have the start part. First of all, you see this thing here. So if we have any element, so if we have some resistance is there here, this is the 10 ohm resistance, and here we have connected some short path is connected here like this. Here you tell me now in which path the current will flow, you tell me now. Which path the current will flow? Yes, very good morning, Madhav. So this current is I. So this complete current will go in this path only, na? So in this path current we can say this as 0, isn't it? In this path current is 0. There is no flow of current, isn't it? Current is completely 0 in this path. Okay. Now, so we can say if this current is 0, voltage is also 0 only, na? Current is 0, voltage 0, then this element is called as a dead element. This element is called as what element? Dead element. If the voltage 0, current 0, that is a dead element. This dead element does not affect the circuit operation. So that's why what we can do, this dead element is disconnected from the network. Will disconnect from the remove the element. Okay. So now by removing this thing, we can redraw the circuit. Yeah, tell me now how we have the circuit. So carefully redraw the circuit now. So with this problem, you will get to know confidence in the calculation of equivalent resistance. And this is P and this point is given as A, this point is given as B, and there is a short path is there here to here. That short path is there. And here we have this is 3 ohms, this is 1 and this is 6 ohms and this is 4 ohms, 1 ohm and this is 2 ohms and this is 5 ohms. Okay. Now let's find one by one here. First bit RXY, resistance between X to Y we need to find now. So that means we need to see the X to Y, we need to see the path we need to identify. Yes, draw the X to Y path, you tell me now, RXY. So X to Y path we need to identify. So X is the starting point, Y is the ending point. X is the starting point, Y is the ending point. So first of all, what we need to do here, so here X, the current has started X, Y has to go to Y. So whatever the extra tails are there, now those tails we remove it now, simply. So they should not be, this tail we can remove now. This tail we can remove extra tails. Only the we need the tails are only X to Y only required. Extra tails we can remove now. Now, so this tail, this open path, here also no current will flow, tell me now. Here also no current will flow, tell me. Isn't it? This is the effective circuit, you tell me. So in this case, so tell me the equivalent resistance now here. So 3 and 6 are parallel and series. So that means RXY. So that is what I can say now, 3 parallel to 6. Thereafter, for this combination, 1 is in series. So how much this value you can tell me now? Yes, which will be equal to 2 plus 1, 3. Okay, got it. Right, next, what else we need to see here? X2Z. So tell me now, we need to get this as R. X2Z path we need to see. X2Z path, you tell me now. X2Z. Now tell me now extra tails we remove now. So extra tails. Now X and Z only tails required. Remaining tails we have to remove now. So Y not required, removed. P not required, removed. A required, no. That means while removing A, this also removed now. And so this also has to be also not required, remove it now. And so this also open path now, remove it now. So what is the X2Z path now here? So yeah, you tell me now here this current will start like this and finally current has to end at the Z now. So you tell me now after reaching here this is short path is there now, current directly सीधा ऐसा जाएगा. In this branch current is 0. So current 0, that is a dead element now. We can remove that element completely. So which will be equal to 0. All of you tell me. XZ. Next you tell me now X2P. And we need X2P need now. So let's find the X2P now. X2P. So identify the path you tell me now. X2P. XP path you tell me now. Identify the path for X2P. X and P only tails required. So this one not required, remove it now. A not required, removed. B not required, remove it now here. Y is not required, remove it. This is the connection, tell me now. The current has started where you tell me now here X and finally end at the P now. This is I, this is I. Okay. Now, so you tell me now here the current which is going to this side. So this current does not come back here. So then how much this current now? This current is 0. So this path is not affected now, though this path is removed completely. So how much is RXP now? Tell me now, which is equal to 5 plus 2, that is equal to 7. Everybody tell me. We need YP required. So this is RYP. Tell me now, RYP. And tell me the path for Y2P here. Y the starting point, P is the ending point, right? Y is the starting point. So X not required, remove the tail. Z not required, remove this tail. A not required. And B also not required. Right. Now tell me now here. Y2P. Now you can see now how these 3 and 6 are in parallel. So what will be the RYP now here? The current has started Y, finally end head at the P. So this is first will experience a 1 and here 3 and 6 are parallel now. 3 parallel to 6 plus after that 5 after that plus 2 now. So finally RYP, how much you tell me now? 1 plus, this is 2 plus 5 plus 2, which will be equal to how much you tell me now? 10. Right. Here these two are in parallel. All of you, right. Next, what else we need to find now? ZP we need to get now. Z2P. So this is RZP. Tell me now Z2P. So Z2P path we need to identify. Tell me now Z2P now here. Z and P only tails required. So X not required, remove it now. Y not required, extra tails, remove it now. A not required and B also not required. Now tell me now here. The current will start at Z and finally reach at the P now here. Tell me now how the flow here. This current so simply straight away will go here now. This is the short path now. So this current is I. So here there is no flow of current in this branch now. Tell me. So these 3 and 6 are dead elements. Now you can tell me now here R ZP. RZP, which will be equal to what? Tell me now, 5 plus 2, which will be equal to 7. Next, yes, RAB, A to B. Yes, now you tell me now A to B path. A to B path will identify. So A and B only tails required. Remove this X tail, Y tail, Z tail. We remove like this now. Yeah, you tell me now. The current has to move from A to B. So this current A started, finally reach at point B. So this current will start it like this. After coming here, the current Sida will go in this branch only na short path only. Here there is no current through 3 and 6. So that is a dead element. Right, so that means what you tell me now, RAB, which will come to be a 1 plus 5 plus 4, which will be equal to how much now? 10? Is 10. Right. Next, AY. A to Y will find RAY. Tell me now here, RAY. A to Y now. Tell me now A to Y. A to Y only tails we can keep, remaining tails remove it simply. Yeah, tell me now, P not required, remove these things. Yes, Z not required, B also not required, and X not required. Yeah, tell me now here. Yes, how the flow of will come here. This current is I, finally reach at point Y. The current will start like this, like this, like this. Here the current will go. So we'll divide now here. Some kind will go here, some kind will go here. That means 3 and 6 are in parallel. So tell me now this is RAY, which is equal to 1 plus 5 plus what? Tell me now 3 parallel to 6 plus 1. Tell me how much now? So which will be equal to 1 plus 5 plus this is 2 plus 1 which will be equal to 9. Very good. Next, BY, tell me now, B to Y. So that is RBY. B to Y path. Tell me now path. B to Y we need to see now here P not required and Z not required, A not required. So that means this branch completely will remove it now. X is also not required. Yes, this connection. Tell me now how this connection now here. So current will start at B and finally end at Y. So what type of connection you can see now here? So this is RBY, which is equal to what element of 4 plus, we can say now 3 parallel to 6. 3 parallel to 6 plus 1. So how much this value, which is equal to 7. Very good. PY. Next we need to find PB. PB. So this is RPB. Tell me now, RPB, P2B path. P2B path only required. We need P2B only. So remove this thing. Z we removed, and A we have removed, and Y removed, and X is also removed. Now tell me the path now here. This current will start here. The current will end at P here. So this means here after coming this complete I will go here only. There is no flow of current in 3 and 6 now. 3 and 6 are dead elements. So that means what I will get now, RPB, which will be equal to 2 plus 5 plus 4. Check it everybody. Yeah, which will be equal to 11. Very good. Next, finally BX. B to X you tell me now. BX. B to X. Tell me now B to X. So P not required, A also not required. Right, Z is not required, Y not required. Yes, tell me now here. So B to X. So this current which is started at B, so it will go like this now here. There is no flow of current here. So सीधा ऐसा जाएगा. That means what we can say now, RBX, which will be equal to 4. Isn't it? Badhiya? Everybody got it now? Yes. So we have calculated all these things. So I think with this, you got a confidence how you need to find the equivalent resistance, right? Understand now how you need to approach now, everybody? So, Badhiya? Chaliye. Now, let's move to the next type problem. Next problems. A wire of resistance capital R, radius is small r, is stretched till its radius becomes R by 2. If the new resistance of the stretched wire is X into R, then the value of X is. Yeah, tell me now, basically, do it now here. The resistance of any wire, which is given as rho into L by A. The wire is stretched. So that means, remember here, whenever the wire is stretched, elongated, in those cases, volume remains constant. When a wire is stretched, what happens now? When a wire is stretched, length increases, but area of cross section area of cross section decreases, isn't it? Area of cross section decreases. But volume remains constant, remember. Volume remains constant. Okay, volume is constant, keep in mind. So that's why we're multiplying with the A divided with the A here. Then will come to be a what, tell me now? This is rho into A into L. Area of cross section to length is called as a volume. Volume by what we can say now? This is A square. All of you. Now this rho is a resistivity. Resistivity is a constant, volume constant. From this we can write as R proportional to 1 by A square. What is A is a pi R square. That's why we can write as R proportional to 1 by R power 4 na. Small r is a radius. Right. So from this we can write it as what will be now R1 by R2, which will be given as R2 by R1 whole power 4. So from this we do simplify it. R1, so that is R by what we can say now, this is R2, and which is equal to R2 by R1. R2 by R1. So what it is R2 now here? Radius is R by 2 by small r na whole power 4. Yeah, you tell me now what will come here? R by R2. R by R2, which is equal to what? Tell me now. This small r will get cancelled. This 1 by 2 power 4 means 16. So this is R2 will come to be what? Tell me now. 16 into R. Okay. Understood this one? The current in a conductor is expressed as like this I. Now they are asking to find what, tell me now, the amount of electric charge that flows. Electric charge we need to find flows to the cross section of a conductor from t is equal to 1 to t is equal to 2 seconds. Tell me now how we'll find this current now. So that means current is given, I value given, we need to get the charge we need to get now. 3t squared plus 4t cube. So that is q is equal to what we can say, tell me now, integral of I into dt. Integral of I into dt. Okay. So you can tell me now this is q is equal to, that is integral of I. So I value given us what, tell me now here, this is 3t squared plus 4t cube into dt now, tell me. So then integrate now, limits are what, tell me now, 1 to 2 seconds. So will come to be what, tell me now, 3t cube by 3 plus what we can say now 4 into t power 4 by 4, and that is 1 to 2. Now you can find out now this q value how much now? This is t cube plus what, tell me now, t power 4. Limits are 1 to 2 now. So tell me how much now here, upper limit, which is 8 minus 1, lower limit, so that is 16 minus 1, will come to be a what, tell me now, this is 7 plus 15. So that is which will be equal to what, tell me now? 22 coulombs. Okay, 22 coulombs. Electric toaster has a resistance of 60 ohms at room temperature. Okay. The toaster is connected to a 220-volt supply. If the current flowing through it reaches to 2.75 amperes, the temperature attained by the toaster is. Now what they're saying here, an electric toaster has a resistance of, so that is 60 ohms. That means at initially the resistance R1, which is equal to 60 ohms, at a temperature T1 is given as what, tell me now? 27 degrees Celsius. Now they ask him to find the T2 value. T2 value they ask him to find, alpha given. Yes, when they're connected to a toaster, supply is connected 220 and current is 2.75. So because of that there is a resistance now, because of the flow of current, R2 is given as what I can say now? V by I now. So from this we can get the resistance now, which is equal to V value, how much now? 220 by 2.75. Can you tell me this means how much this value? So how much this resistance value? Tell me now. 220. Yes, 220. 220 by 2.75. So this is 80. Check it all of you, this thing. I got this as 80 ohms I got. Now alpha value given. Alpha value given. We know the variation of resistance with respect to temperature. That is given as R2 equal to what I can say, this is R1 into 1 plus alpha into delta T. Delta T is the change in temperature. Alpha is the temperature coefficient. So this is 80 equal to R1, which is the 60. That is 1 plus alpha value 2 into 10 power minus 4 into delta T, change in temperature. If we simplify it now here, 0 will get cancelled. So this value 1 plus 2 into 10 power minus 4 into delta T, and which will be equal to what, tell me now? 4 by 3. So that is 2 into 10 power minus 4 into delta T, and which will be equal to 1 by 3. So that means delta T will come to be a what, tell me now? 10 power 4 by 6. So how much this value, tell me now? 10 power 4 by 6. So this value delta T, we are getting this delta T, which we got it as 1666.6. Okay, so this is the T2 minus T1 na? So this is T2 minus T1 value, how much? 27, which is equal to 1666.6. So this value plus 27 will do. So this T2 value, how much now here? 1693 degrees Celsius. Okay. The electric current through the wire varies with the time as given like this. The amount of electric charge crossing through a section of the wire in 20 seconds is. The electric current, so this is I, which is given as I naught value given as a 20 plus beta value given 3 into T. Now they ask him to find the amount of electric charge crossing. So we need to get what element of charge we need to get now. Charge equal to what element of integral of I into dt. Charge equal to integral of I into dt. So that is Q value, which will be given as integral of, this is 20 plus 3t into dt. So from way to way now t limits are from 0 to 20 seconds. So tell me now, integrate now. So this Q value, which will be equal to what element of 20 into t plus what element of 3t square by 2. Limits are what we can say now, 0 to 20. So this Q value will come to be at 20 into, this is 20 minus 0 plus what element of 3 by 2 into 20 square means 400 minus 0. Tell me how much the charge will come. This is 400, and so this value plus 3 by 2 into, so this is 3 into 200. So that is 600 plus 400. So that will be equal to how much now? 1000 coulombs now. That is equal to 1000 coulombs. Okay. Next one. A wire of resistance 160 ohms is melted and drawn into the wire of 1/4 of its original length. That means I have the wire, that wire is completely melted. That means volume remains same only. Jaisa previous volume, same volume say we made, but the length is 1/4. So they mean, so here this is volume is constant. Hana boliye. And this is, so final length L2 is what, tell me now, that is L1/4 they are saying. 1/4 of the original resistance. So you tell me in this case 1/4 they are saying. So now, so the resistance R, which is equal to what, tell me now, rho into L by A. They given in terms of lengths. So we'll get in terms of length only. Multiply and divide with the L here. Now we'll commit as what, tell me now, R is equal to, this is rho into L square by V. Now V is the volume. V is the volume. Volume is constant. So from this we can write as R proportional to L square. Fine. So that means what I can say, tell me now, R1 by R2, and which is equal to what, tell me now, L1 by L2 whole square. R1, which is equal to 160 by R2, which is equal to L1 by L2 is what, tell me now, L1 by 4 whole square. Then simplify now, how much will come? So this is, sorry, 160 by R2, which will be equal to 4 square, that will come 16. So from this R2 value will come to be how much now here? 10 ohms. Option A. The length of a metallic wire is increased by 10-20% and its area of cross section reduced by 4%. The percentage change in the resistance of the metallic wire is. Now tell me now they given. So if I call this as a L1 length, which is equal to 100. Now what will be the length L2 now here? Increased by 20%. So that means it will be a 120 now. Next, area of cross section A1, which is 100 if I say initial area, and A2, this is decreased by 4% means how much now? 96. This step you understood now, everybody? Now tell me now the resistance of a material which will be given as R is equal to what you tell me now? Rho L by A. The resistance rho is a constant which is directly proportional to L by A. That we can write it as R1 by R2 and which will be equal to what I can write now L1 by L2 into what tell me now A2 by A1. So now substitute the terms. So this is R1 by R2 which will be given as L1 by L2. L1 is how much now? 100 by L2 is 120. A2 value 96, A1 value 100. So that means R1 by R2 हमको कितना आएगा? So that means 96 will cancel with the 4 से cancel now. This is 4 2s, 4 4s, 4 3s, 0, 3 10 and 3 8, 2 4, 2 5s. That is what will be now 4 by 5. That means we can say now R2 by R1, which we got it as what tell me now? That is 5 by 4 we got. We need the percentage of change of any quantity. How we can find, you tell me now? Percentage of change of any quantity, that is given as R2 minus R1 by R1 into 100 we need to get. R2 minus R1 by R1 into 100. So this is the percentage of change of the any quantity. So that means what we can write now, this is in this case this value, this percentage of change, which will be equal to what we can say now, this is 5 minus 4 by 4 into 100 will come it as 1 by 4 into 100 now. That means which will be equal to 25. 25%. They are asking in terms of percentage now. We need to give the percentage we have to give. Understood this thing? Tell me how we did this one. Percentage of change means what will be now? Basically final value minus initial value by initial value into 100. Basically percentage of X if they are asking to find. If I want percentage of X, which means what we can say now, that is X2 minus X1 by X1 into 100. Final minus initial by initial into 100. The same thing, R2 minus R1 by R1 into 100. Next. The resistance of a wire is 5 ohms. Its new resistance if stretched to 5 times. That means stretched. Then which is constant, you tell me now. Whenever the stretching is done, do remember volume constant. Volume constant. If the volume constant, now you can tell me now resistance which will be equal to rho L by A. We have multiplied with L. That means will come it as rho into L square by V. So that means R proportional to L square I can say now. So rho and V are constants. So we can write this as R1 by R2 and which will be given as L1 by L2 whole square. So this R1 which is equal to 5 by R2 value we need to get, and L1 value we have, this is L. L2 is a 5 times the L na whole square. Now you can tell me now, this is 5 by R2 which will be equal to 1 by 25. That means R2 will becomes what, tell me now, 125. Right. So after completion of the class, in the description may you will get one link, you will get that link. So that in from that link you can download the class notes, or also you can able to download complete notes, you can able to download. Next one. The charge flowing in a conductor changes with the time as the given Q of t given as like this. The minimum value of current is they given charge, they ask him to find the current, and that to minimum current they given. So first of all, can you find the current now? Can you find the current now? First of all, how will get this current from the charge? You tell me now. I is equal to what we can say now here. That is dq by dt. I is equal to dq by dt, right? So this will come to be what tell me now, alpha minus 2 beta t plus what we can say now 3 gamma into t square. This is the current now. Fine. What they are asking you tell me now here? They asking the minimum current. How to find the they given some function is given, f of x is given. They ask him to find the minimum value of function. How will find the minimum value of any function? Remember the procedure. Will find f dash of x, will find, will equate it to 0, then we'll get the x values will come. Those x values will substitute in the equation, we can get the minimum value of function, isn't it? The same thing will proceed here also. Now we need to get the minimum value of current. So let's get the minimum value of current now first. What we should do here? So we'll differentiate now here. So differentiate and di by dt. Tell me now di by dt will come it as what? Tell me now minus 2 beta plus what? Tell me now 6 gamma into t, and will equate it to 0. By equating to 0 we'll get t values, roots will come. What is the t values? You tell me now here. This is 2 beta by 6 gamma will come to be what? Tell me now beta by 3 gamma. Isn't it all of you? This is time. So now we need to get what? Tell me now minimum current now. For that we'll put this value now. So this is I minimum. We need to put this value in this current equation. So that is what? Tell me now alpha minus, this is 2 beta into t. How much the t value? Tell me now. So this t value which is equal to beta by 3 gamma plus what? Tell me now 3 gamma into t square means beta square by 9 gamma square. So simplify now, how much will come? This is alpha minus, that is 2 beta by 3 gamma beta square. Okay. Next, what we have? Tell me now. Plus, this is beta square by 3 gamma. Check it all of you. So this means I minimum will come from this. That is what? Tell me now alpha minus, that is beta square by 3 gamma. Isn't it? Beta square by 3 gamma. Everybody got the same thing? Tell me. So alpha minus beta square by 3 gamma. So this is option na? Option D. Next, if a copper wire is stretched to increase its length by 20%, the percentage increase in resistance, the similar kind of problem we did earlier also. Now we can solve it now. Yes, whenever stretching is done, what happens? You tell me now. Whenever stretching is done, what happens? Volume constant. Length increases by 20%. So that means if I say initial length is 100 and the new length is how much now? Increased by 20%. So that means L2 will become how much now? 120. Right. So volume constant here, stretching means what I can say now, R proportional to L square. Now everybody tell me this step. Directly we can say R proportional to L square since volume is constant. So from this we can write it as what? Tell me now. This is R1 by R2, which will be equal to L1 by L2 whole square. That is R1 by R2, which will be equal to L1 by L2. L is 100 by L2 value 120 whole square. Then finally we have R1 by R2, which will be equal to 5, 6, 25. 25 by 36. Right, 25 by 36 now. Now from this we can see this is, I can say R2 by R1, which is equal to 36 by 25. We need percentage now. Yeah, tell me the percentage means that is R2 minus R1 by R1 into 100. So that means what? Tell me now, 36 minus 25 by 25 into 100. Okay, simplify and tell me how much will come. This is, we can say delta R by R percentage into 100, which will be equal to how much now? This is 11, na? 11 by 25 into 100. So, which will be equal to 44%. Okay. Done. Yes, all of you do like the session. Share to all your friends. All of you do like the session. Next one. Yeah, tell me now in this case what they're saying here. A 1 meter long wire is broken into two unequal parts X and Y. Two unequal parts X and Y. The X part of the wire is stretched into another wire W. The length of W is twice the length of X. And the resistance of W is twice that of Y. Oh, very much confusing. So, try this thing here. A 1 meter long wire is broken into two unequal parts. Okay, first thing, two unequal parts. So let us say this is the X wire and this is the Y. This length I am calling it as LX. This length I am calling it as LY. So now they cut into two parts now. Okay. X part of the wire is stretched into another wire. So this X part of wire is stretched to another wire, that is W they given. Okay. The length of W, so this is length of W stretched now, that is given as 2 times the length of x. Okay, length is stretched. So that means volume constant. Length increases by 2 times. Then the resistance increases by how much, you tell me now from this? From this we can say resistance of W is what I can say now. 4 times the resistance of X, I can say, all of you. Right. Next. And the resistance of W, that is resistance of W, they given us what, tell me not, twice the resistance of Y. Now resistance of W, that is given as 4 times the resistance of X, that is 2 into Ry. So that is 2 into Rx, which is equal to Ry na. Initially, the x and y's are we got by cutting into two parts. That means resistance proportional to L only now when the cutting is done, R proportional to L. So that is 2 into Rx, we can say it as rho into Lx by area to same only now, same while we did everything. That is what I'll be now rho into, we can say now Ly by A. So from this, what we have now here, 2 into Lx. Okay, 2 into Lx. So we have now, that is 2 into Lx equal to Ly. They are asking the Lx by Ly now. Lx by Ly, which will be equal to what, I'll be now 1 by 2. So 1 by 2. Understand the problem? Tell me everybody. बढ़िया लॉजिक है इसमें. Next one. A wire of resistance R1 is drawn out so that its length is increased by twice its original length. Length is increased by twice its original length. The ratio of the new resistance. So direct problem now, tell me now. So this means now this L2 equal to what, tell me now, 2 times of L1. So that means, tell me now. That means what I can say now, R2 resistance proportional to what, tell me now, L square. So R2 equal to 4 times R1 now, tell me now. The new resistance, that is R2 by R1, which is equal to what, tell me now, 4 by 1. Right. The variation of applied potential and the current flowing through a given wire is shown in the figure. The length of the wire is 31.4 centimeters. The diameter of the wire is 2.4 centimeters. The resistivity of the given material measured as this much. Okay, they given voltage and current is given this graph. So you can see now here. So resistance R is equal to what, tell me now, V by I. That is nothing but slope only now, tell me. Slope means tan theta. So slope means that is also tan theta na. That is a resistance. So that means R is equal to theta value given 45 degrees. So that means indirectly resistance they given as 1 ohm. Okay. Indirectly given the resistance as 1 ohm. Now we need to find the resistivity. R is equal to what, tell me now? Rho into L by A. Here this rho value we need to find R is 1. So how much is rho value? Tell me now. This is equal to A by L. So this is rho is equal to A value pi r square na. R square. Diameter given 2.4. They ask in answer the centimeters only. We can keep the centimeters only. 1.2. Yes, pi r square by L. Length is given as 31.4 centimeters. Now this pi means 3.14. So that is rho value will come to be this is 1.44 by 10. So this value will come to be 144 into 10 power minus 3. This is ohm into centimeters. Next, length of a given cylindrical wire is increased by double to its original length. The percentage increase in the resistance is, okay, they given L2 is equal to 2 times of L1. So that means R2 will becomes what? Tell me now. So this 4 times the initial resistance now. Why? Because stretched now. Here this is R proportional to L square. And percentage of increase of resistance. Percentage of increase of resistance, which is given as what we can say now. This is R2 minus R1 by R1 into 100 now. So this is 4R1 minus R1 by R1 into 100, which will be equal to what? Tell me now. 300%. Okay. Next. An aluminum wire is stretched to make its length is zero point 0.4 larger. So this means they given the length is increased by how much now? Delta L by L into 100. They given us how much now? 0 0.4. Stretching is done volume constant. Stretching is done means volume is constant. So that means volume constant means R proportional to L square na. So from this we can say write it as delta R by R into 100, which will be here the change is only less than 5%. We can use this formula. That is, this is will come to be what terminal 2 into delta L by L into 100. So how much this value? This is 0 0.4, which will be equal to 0.8%. In the given figure, the resistances they given, the battery is ideal with EMF 12 volts, the equivalent resistance of the circuit, and the current is. Yeah, find the equivalent resistance now. Right, so you see this thing, how these three resistors now here, all these three are in parallel. So this means what we can say now, 8 parallel to 4. That means how much now? 8 by 1 plus 1 plus 2 na. So that is 8 by 4, which is equal to 2. And 2 and 10 are series. So that's why R equivalent will come to be how much? You tell me now. 10 ohms na. R equivalent is 10. Now we need to get this current. I is equal to what? Tell me now here. 12 by R equivalent. So that is equal to 12 by 12, which is equal to 1 ampere. So option B. Right. So understood this thing, how to solve this thing. Yes. So all of you do like the session. All of you do like the session. Share to all your friends. Right. So in the same manner, daily the same time will continue our classes, and this course will be helpful for the students who are preparing for GATE 2027 के लिए who are preparing for them बहुत काम आएगा. So for इसी को भी electrical instrumentation students. So use this thing here, and if you are regularly following this in the same manner, so I will plan the next courses also. I will plan for you. I will plan the next. Next we plan. We do the controls, digital signals, other courses also. I'll plan. Okay. So this thing, and do follow these classes regularly. Regularly do follow properly. The same timings we'll plan the classes there. So 9 o'clock we do that one, and so we'll see this thing, and do follow classes, and do share to all your friends. Do share to all your friends, and if you have any queries and all, you can discuss with me. Right. So I hope all of you आज का session में मजा आया होगा. I think so. The same manner we'll do the remaining things. So do try to follow the classes regularly. Done. Yes, that's it for today's class, and next class will continue the, and और भी ज़्यादा problems हम continue करेगा. Okay. Okay then. See you. Bye bye.